You won't survive the next night because a black hole will devour you and all the information about you will simply disappear. You won't die. It's just that every single piece of information about every atom of you will vanish forever, as if you never existed at all. Not even a single atom of you would remain. That's what would happen if you fell into a black hole. But let me explain in more detail what I mean. So, what exactly are black holes? They're not science fiction, not myths, not scary bedtime stories. They are real physical objects that exist in our universe, somewhere far away in space. And they carry great importance. Honestly, they might be one of those things that completely break the laws of physics. Listen carefully. Black holes are regions of space where gravity is so strong that even light cannot escape. They can form from the gravitational collapse of massive stars or from the merging of other cosmic objects. Even though we can't see them directly, we can observe their influence on nearby space. The motion of stars, the X-ray radiation from hot gas, or gravitational waves.
So yes, we literally cannot see a black hole. It's like how you can't see the vortex inside a tornado. You only see the debris swirling around it. And from that, you know something terrifying is inside. The same goes for black holes. They're basically a point with an incredibly strong gravitational field, a gravitational anomaly, if you will. What do scientists say about them? In 1965, mathematician Roger Penrose proved a theorem showing that under certain conditions, Einstein's general theory of relativity predicts the formation of singularities. These are the points where spacetime itself breaks down, where curvature becomes infinite. You heard that right. You don't need the infinity stones, because in real life, such an object actually exists, and it's called a black hole.
When Penrose published this, it was revolutionary. Before that, people thought singularities were just mathematical artifacts or flaws in equations. But Penrose showed that they could form naturally, literally, through the process of gravitational collapse. Sounds scary? Hold on. Later, another scientist, Stephen Hawking, combined this with quantum physics and showed that a singularity isn't just a meaningless mathematical point where matter collapses. It's a real physical anomaly in our universe. Meaning, good old Newton might have been wrong about some things after all. But never mind that. Let me explain it differently. Imagine a spring. You keep compressing it tighter and tighter, until at some point it stops being a spring and just snaps. In mathematics, a singularity is a similar kind of breaking point, where all our physical laws tear apart. In 1974, Stephen Hawking introduced one of the most unexpected ideas, that black holes aren't completely black. He proposed that quantum fluctuations of energy can occur at the event horizon, causing one particle of a pair to fall inside while the other escapes outward. This phenomenon is called Hawking radiation. Through this, Hawking showed that black holes can actually lose mass, slowly evaporating over time, though extremely slowly. And even though we can't directly observe it, because our eyes simply aren't made for that, it's a real process. It's like air. We can't see it, but it's always around us. Imagine a sealed black box leaking gas ever so slightly, so slowly that you'd never notice until it's completely empty.
And what about the information paradox? If information about matter falls into a black hole, does it disappear forever?
Quantum physics says no. Information cannot be destroyed. That creates the so-called information paradox. A new idea being discussed today, the island formula, suggests that part of that information could be preserved in the form of quantum entanglement, even if the matter itself is gone. So, when you fall into a black hole, you don't exactly die. You just stop existing for the outside world. Inside the black hole, time freezes for you, and all the information about you remains trapped within. If the black hole is massive enough, larger than our sun, you wouldn't even feel pain or notice anything. It would be like entering a frozen state. Recent studies, like the 2023 Radboud team's research, suggest that black holes may evaporate not only through Hawking radiation, but also due to the curvature of spacetime itself. And now scientists are trying to unify quantum gravity with general relativity to understand what truly happens inside these cosmic monsters.